Hi everyone. In this lesson, I'm going to be going through solving quadratic equations. And look, if you've been factorizing quadratics, trinomials, difference of perfect squares, and all that sort of thing, then you should find this fairly straightforward because we've just got to solve them. And I guess if we start sort of thinking about, what does solving them do? Well, I guess if we have a quadratic. Let's just say if I've got a quadratic in the form y is equal to, let's just make one up, x squared plus, let's say x squared plus 7x plus 12. And of course, we can then go and factorize this. So I want two numbers which multiply to give 12 and to give 7. That would be equal to x plus 4, x plus 3. And then, of course, why are we solving these? Well, when we start thinking about sketching these quadratics, then we know that the x-intercept is when y is equal to 0. So I'm going to go and let y equal 0. And how does this equation, how is this true? Well, we're going to be using what's called the Null Factor Law. And if this is equal to 0, then there is two things. X plus 4 is equal to 0, or x plus 3 is equal to 0. So this thing could be equal to 0, or this thing could be equal to 0. And so there's two cases in which that's true. So x would, in this case, have to equal -4, and in this case, x would have to equal -3. And so basically what we're doing is effectively this process of factorizing and solving is sort of going to find our intercepts. Okay, so I might have, so there you go, I've got sort of a quadratic which might go something like this. There's my x-intercepts. And we can find the y-intercept later as well. Well, the y-intercept's when x equals 0. So when x equals 0, then the y-intercept would be 12, wouldn't it? So that's why we're doing all of this. So later on when we start looking at parabolas and stuff, if you have an equation, a quadratic, you'll need to factorize and solve and use what's called the Null Factor Law. Okay, so just quickly, if I just practice with you a couple of questions. If I was to factorize, these are already factorized, then what are the solutions? Well, if this is equal to 0, first of all, you can see that x could be equal to 0, or x plus 1 would have to equal 0, which means that x is equal to -1 in that case. So I've got 2 solutions. Now, in a quadratic, you can either have 2 solutions, you can have 1 solution, or you could have 0 solutions. That's just depending on how many times we, so for example, I could, this example where it just touches the x-axis, that would be 1 solution. Here's an example of 2 solutions. And of course, if I had some quadratic up here, which had a turning point above the x-axis, then that would have 0 solutions. Having a look up here, we've got 2x, x minus 4, is equal to 0. Well, if this is already factorized like this, then that means 2x would have to equal 0. And also x minus 4 would have to equal 0, which means that x would equal 0 and x would equal 4. And we could keep going through over these. You could see over here, the solutions to this case would be x is equal to 3 and x would have to equal -2 in order for those to equal 0. So that's your Null Factor Law. All right, let's get straight into some examples then. I won't take up too much of your time. First of all, over here we've got a quadratic. It's not a trinomial though, there's not 3 expressions. So these ones here, we can just take out our highest common factor, which we have x. And that would give us x minus 2 inside the brackets. And we're asked to solve. So whenever we're asked to solve, then we have to find x, don't we? So using the Null Factor Law, I'll do it the long way. And that means that x would have to equal 0, which is this guy here, or x minus 2 would have to equal 0, which gives us x is equal to 2. So we've got two solutions for that one, x equals 0 and x equals 2. Now, this one over here, we don't have a trinomial, but you might recall that this is the difference of perfect squares. So we'll do this. We'll set it up like this. Now, what would go inside here to make this, whatever squared, something squared, to be 15? Well, it's the square root of 15. Now, of course, that is equal to 0. So we just leave the right-hand side as it is, and then we just factorize this. We've been factorizing these expressions, but we haven't been factorizing equations because we haven't sort of seen an equal sign. So now let's go ahead. That's x minus root 15 and x plus root 15, and that's equal to 0. And now, of course, we just want to find that x is equal to, well, what would it have to be equal to in here for that to be equal to 0 using the Null Factor Law? Well, that would be x is equal to root 15. And over here, we've got x is equal to minus root 15. And a good way of writing that actually is x is equal to, well, we've got positive root 15 and minus root 15. So we can write it like this, plus minus root 15. So that's representing my two solutions, positive and negative. All right, now over here, once again, well, this one we don't have to factorize as such. Well, we could. But we could do this two ways. We could divide both sides by 2, which is going to give us x squared is equal to 25. And then we want to take the square root of both sides. Just be careful, though. When you take the square root of x squared, that's x. But you've got to consider that there's two possible outcomes. X could be positive, and it also could be negative. So, as in actual fact, there is two solutions to this equation. All right, because if you think about it, the square root of 25 is 5, but we know that negative 5 times negative 5 is 25. We know that positive 5 times 5 is also 25. So if I'm taking the square root of 25, then there's actually two solutions, plus minus 5 in this case. All right. Now, I'll get you just to try these ones just really quickly. So I'm going to pause this now and have a go. All right, so as you can see, I factorize, I take out the highest common factor of x. So that gives me x times x minus 3. Using our Null Factor Law, that means that x is equal to 0 or x minus 3 equals 0, which would mean x equals 3. Two solutions. Over here, we've got our difference of perfect squares. I've just changed that to x squared minus root 11 all squared, which means that that's factorizing as x minus root 11, x plus root 11. Of course, you've got to recognize that that is the difference of perfect squares. And finally, I've just divided both sides by 3, so it gives me x squared equals 9. Taking the square root of both sides, though, we're going to have to account for the fact that there's going to be a positive and a negative solution. So positive plus minus the square root of 9 is plus minus 3. So there's two solutions there. Okay, so as you can see, if you can factorize, now of course these ones, look, if I just didn't have the 0 here, we would just factorize them, wouldn't we? And we've been doing that. So we're going to do these together. And this time, rather than just factorizing them, we're actually going to solve these equations. So if you can factorize and you can use the Null Factor Law, then you can find the x-intercepts of a quadratic, these sort of parabolas that we're going to have a look at soon. All right, so I need two numbers which multiply to give 6, and they add to give minus 5. So I've got, well, we've got minus 3 times minus 2 is positive 6, and minus 3 plus minus 2 is minus 5. So there's our two magical numbers. So here we can factorize, but this time we have an equation, not an expression. So x minus 3, x minus 2, and of course it's equal to 0. Now, so usually, of course, we would stop if we had just an expression, but we've got this equation here which we're solving. So we need to find our value for x. So the long way is, well, x minus 3 would have to equal 0. and or x minus 2 would have to equal 0. That's our null factor law. And now let's go ahead and state a solution. So that means x would have to equal 2 or 3. So I'm just going to write my two solutions. X is equal to 2 and 3, and we are done. Over here we've got, now this is an example of, you're not always going to get two solutions. You can get 1 or even 0. Now, if I need two numbers which are multiplied to give 1, but they add to give 2, and of course those are 1 and 1, like so. So therefore I've got x plus 1 is equal to 0. As you can see, I've got a repeated factor there, x plus 1. So that's the same as x plus 1 squared, if you like, is equal to 0. So how does this expression equal 0? Well, it only equals 0 when x is equal to negative 1. So look, just so to give you some a background, when we're sort of looking at quadratics, we basically got a quadratic here where it has sort of this turning point right here, and it just touches the x-axis, and there is only one solution, okay, because it just touches. All right. And finally, these, I guess, were the harder ones because we've got the non-monic trinomials. So what we have to do is we need two numbers which are going to multiply to give 10 times minus 3. So it's going to two numbers which multiply to give minus 30, and they add to give minus 13. So if you think about the factors of 30, we've got 1 and 30, 2 and 15. If I did 2 and 15, that could work, couldn't it? I'd say so. Let's have a look. So if I do minus 15 times positive 2, that's negative 30, and minus 15 plus 2 is equal to minus 13. So we then have to bust that second term up, that minus 13x, into minus 15x plus 2x minus 3. And we now factorize using grouping. So I'm going to group these two together. Highest thing that goes into each of those is 5x, and that would give me 2x minus 3. And look, that's the hint there. If I've got a 2x minus 3 over there, then I really want to see that again. In actual fact, I can just put out a 1 out there. So we're almost there. We now need to, so of course, that is, we're factorizing now. So let's factorize that. So we can sort of say that we've got 5x plus 1 times 2x minus 3 is equal to 0. And now in order to solve, we can use the null factor law. So a lot of these ones, like for example over here, these ones here, well, it's pretty easy to see what they are, but you might want to write out this one. This is going to be a fraction. 5x plus 1 is equal to 0, or 2x minus 3 is equal to 0. So now we want to solve these. We want to get the 1 onto the other side, so it's 5x is equal to negative 1. Dividing both sides by 5, x is equal to negative 1 over 5. And over here, we've got add 3 to both sides. 2x is equal to 3. X is equal to 3 on 2. So as you can see, you've got one solution, two solutions, and I guess it's a little bit trickier in that they're not whole numbers, they're sort of fractions. All right, now, what I'll get you to do is to try these ones here and see if you can do those. Just remember, we can factorize this one, okay? We'll factorize all of them. But of course, this one here is a non-monic. All right, so I'm going to give you a chance to have a go at those now, and I'll go through those shortly. All right, so with the first one, we are looking at two numbers which multiply to give -12 and add to give -1. So they're -4 and +3. So we factorize, and then using a null factor law, that would have to mean that x would have to equal 4 and x would have to equal -3 for our two solutions. This one's only got one though, because I come up with this, and when I factorize, the only two numbers which come to 9 and add to give 6 are 3. So we've got sort of a repeated factor there. So x plus 3 all squared is equal to 0. So there's only one solution for that, which is x is equal to -3. And over here for the non-monic, we've got two numbers which multiply to give 6 times -2, which is -12, and add to give 1, which is 4 and -3. Breaking that up, grouping them, and then they have 3x plus 2 in common and 2x minus 1. If I multiply 3x plus 2, that will give me that expression. And then, of course, breaking this up and using the null factor law, if this is equal to 0, we've got one equation there, one solution, x equals 1/2, and the other one is solving this equation here, x equals -2/3. For our two solutions. Okay, the last thing I'll do before I'll let you go is you may have some where you actually have to rearrange first, and I won't do those with you because we've been through quite a few, but as you can see over here, we want to get that into this form. We actually want to get everything on one side, have it equal 0. So if I have this x squared, I'm going to expand this out. X squared is equal to 4x plus 60. Well, we want to just get everything to one side. When we want to factorize, we want to have everything on the one side. So we're going to subtract 4x and subtract 60 from both sides. So that's going to give me this. And then, of course, that is equal to 0 when I get it on the other side. And then, of course, it's just exactly the same. So we go ahead and solve it. We just need two numbers which multiply to give -60 and add to give -4. So that would be x minus 10 and x plus 6 would equal 0. And then, of course, x is equal to -10, positive 10, and it's also equal to -6. So we could write it out like so. Now this one over here, we just have to multiply x to both sides. So I want to cancel out fractions. So I'm going to do that. X times x is x squared. And then I want to subtract x plus 6 from both sides. So what we're going to have is, when I do that, we're going to have x squared take x, take 6 is equal to 0, and then we go ahead and solve. So sometimes they don't look like quadratics, but if you rearrange them, they are. Okay, so that's really all you have to do when you get those ones there. All right, I think that's about it for the time being. Make sure that if that makes sense, then hopefully you can do some of the questions from 5F. Thank you.